Welcome everyone, I'm Kate McCauley, the Marketing Manager at iTech, and on behalf of everyone here and at Pentasys, I'd like to thank you for attending part 2 of our 3-part series called Demystifying the Cloud, where we're taking a deeper dive into cloud computing and virtualization. Today's special guest is Steve Harms, the founder and president of Pentasys. He has great experience in network design, installation, and configuration, but today he will talk about his specialty, cloud computing. I'm sure you will enjoy. On today's agenda, we'll make sure to cover desktop transformation methodology. We'll give you some considerations to think about as we move to the cloud. Then we'll summarize everything we've gone through today and follow up with any questions you may have during today's webinar. With that, let's get started. So we begin with the desktop transformation, where we started with a distributed management. User access was restricted to specific devices, and IT was managing a very complex environment. Today now, we have a people-centric workplace. Everything is centrally delivered with improved security and virtual work styles that are supported. Everything is optimally managed with significant cost and complexity reduction. In the transformation of services where desktops are delivered as a service and self-service IT is provided. So this desktop transformation, there is a paradigm shift happening. It's taking place in companies today as they move from a distributed computing model to a more user-centric virtualized computing model. Today, everything revolves around the device. Tomorrow, it's all about the needs and wants of the user. The device doesn't matter. And most CIOs know this. They know desktop virtualization is the answer. They get it, they want it. The thing is, IT really needs a practical guide to know how to move from the wow factor of cloud computing to how. So the typical transformation from desktop to virtualization really goes in phases from this device to user. And it's the distributed management, essentially delivered management, enabling very virtual work styles, to the optimally managed, which is lower cost of the desktop operations. Then it's finally to the transformed services, delivering usage-based services and simplifying IT support with self-service. So starting with the first type, centrally delivered desktop, you're looking at technology where it's centralized and virtualized desktops. It enables remote access and network optimization and implement app virtualization for problem apps. The process is greatly simplified endpoint security and management. And you'll also see improvements where data is now centralized, rolling out updates will be simplified, all because of a central management. So now in the case with an optimally managed desktop, you're looking at implementing a single instance management, virtualize the majority of your apps, and manage user profiles are centrally located. The process is a simplified application desktop updates as well as rollouts. And you can now repurpose and reassign skills in the data center. Overall, it reduces cost per user, and it simplifies desktop and application management. And lastly, the transformed service desktop. This is your cloud-based model. This is desktop as a service. Technology delivers a simple, self-service user interface for IT services, implementation usage and reporting and billing. It automates workflows for dynamic provisioning. Your budget is easier to manage. There's a fixed to consumption-based cost model, and then build automated processes with user self-service. This is key. This just simply shows how much desktop transformation leads to diminishing costs. Cloud-based saves money. So there's a few things to consider in desktop transformation components. We have to identify the business priorities, establish time to value, and define technology roadmap to go forward. Starting with identifying our priorities. We just need to look at the roadmap. We need to see how much reducing costs, looking at a virtual work style will help, increasing security, business agility, device independence. You need to take all these into consideration. So how do we get here? Well, we need to do it the right way and plan for the migration. The right way is to assess your requirements in your environment. Then we need to identify key areas, your user, the apps, locations, etc. And then determine what you need to migrate. Operating system settings, application settings, user settings. Then test. Always test the migration. And then how the migration performs. Migration projects are massive undertakings that require coordination of hundreds of tasks. tasks that must be correctly orchestrated to be delivered on time, under budget, and with a very high level of quality. Successful migration projects rely on the proper plan, and these are the steps you need to take. And just like in the wise words of Yoda, you need to choose what's right, not what is easy. So take a look at the Citrix VDI architecture. It seems very involved, but don't be afraid. You just need to take some things into consideration: app delivery, desktop model, host resources, and your network resources. So we first need to look at your network considerations, changing from large packets to many packets, high availability, bandwidth considerations definitely, subnetting, and most definitely your security. Then the server resource considerations are what was on your PC is now in the data center. You need to look at that in your processor, in memory. And lastly, storage, because at the end of the day, it's all about the IAPS. And now, to move on, for further considerations and summary, I'm going to pass this off to Steve Harms. Thanks.
So looking at application delivery and looking at moving sort of up the chain, up the ladder, moving up the layers into the operating system in the application layer. How do we deliver? What's the best methodology for delivering applications? The key piece that we have to look at, and this is I keep swearing I'm going to get a T-shirt that says, "What's your use case?" Because that's really what you need to talk about. It's what are you trying to accomplish? What are you trying to do? What kind of an application you're trying to deliver? What kind of an experience you're trying to deliver? And do you do that through Zen App or you do it through Zen Desktop? And very quickly, the distinction between the two is in a Zen Desktop environment, if you're delivering an application through that, then that application is installed on your golden image or the master image that's being delivered to the users. So everybody gets that. Typically what we see in a Zen Desktop or in a VDI environment is a mix, where we look at the golden image because the idea is the fewer master images you have, the easier the overall environment is to maintain. So find those applications that are common among large chunks or large groups of users, embed them into the actual desktop, and deliver everything else through Zen App. In a fully integrated Zen Desktop environment, when the desktop is loaded, applications can be streamed to it from the Zen App environment. The user sees just a single desktop with icons on it, and they have no idea that when they click on this Great Plains Dynamics icon, as an example, it's not actually installed or running in their desktop or in their virtual desktop. It's actually running on a Zen App farm in the data center that is just streaming that application to the virtual desktop. So a significant part of the assessment and design process is looking at how do we deliver applications either through Zen App or through Zen Desktop. The desktop models, there are really a few of them, and I'll let you sort of assess this slide later. I'm not going to go into huge amounts of detail on it, but it gives you a little bit of a comparison of what's required and what the considerations are for each kind of desktop. Existing desktops, physical desktops are obviously physical. In a pooled environment, what you do in a pooled environment and streamed are very similar, but a pooled environment is where I have a single image that I'm delivering to multiple users. You can also create dedicated desktops within a VDI environment. In a dedicated environment, every user has a specific desktop that they access every time they access it. So versus a pooled or a streamed environment where you may get a different, in fact, in all likelihood, you're going to get a different desktop every time you log on. And going back to the first webinar and a little bit into the beginning of this, that desktop is comprised of your image, your user profile, your write-back cache, and things like that that's all put together to create a single image that's delivered to the user. In a dedicated environment, that desktop is always there. The user profile is potentially even local to it. So it's a way of delivering a dedicated desktop or a standard or the same desktop to a particular user. Engineering firms are great examples of where dedicated desktops are very often preferable because you can embed, you can offload some of the graphics processing into the virtual environment, and because they're very high demand, very high resource intensive environments, very often they lend themselves better to a dedicated environment versus a streamed or a pooled environment. Any questions so far? Okay. Then moving into the host resources, we talked a little about this, and I'll go into a little bit more detail on some of this stuff. The CPU resources, now you're looking at, depending on your licensing model from a hypervisor perspective and also from delivery, you're licensing for some of the hypervisors, you need to look at in terms of sockets. In terms of delivery of applications, we care more about cores. So a quad-core hyper-threaded processor is actually going to give us 8 cores to play with and to allocate across the resource pool. Memory resources are something obviously we need to take a look at, how we deliver memory and how fast it is and where it is and so forth. The network resources really have a lot to do with, depending on the application and what we're doing and what the communication is, whether to bond or not to bond. In the case, what essentially we're talking about here is in the streaming aspect or the streaming component of a virtual desktop environment, the more bandwidth you have to communicate between the provisioning servers, the virtual environment, and the desktop delivery controllers, the better that overall performance for the user is going to be because the data is flowing faster. So more often than not, what we'll wind up doing is bonding NICs and creating the corresponding lag groups and the core switches so that we can aggregate multiple network adapters together to be able to deliver greater amounts of bandwidth and the corresponding increase in performance to the end user. And again, going back to storage, it's all about spindles, LUNs, and ports OMI. So these are just pieces that need to be considered. From the, I've spent a fair amount of time talking about the network resources previously, and so sort of by way of review, switching topologies, layer 2 versus layer 3 are things that obviously need to be considered and looked at. If you're not in a layer 3 fundamentally core, at least core environment, it's something you're certainly going to want to look at. I already talked about, excuse me, the packets per second versus megabits per second. The way routing and subnetting, we talked a bit about that, and then again on the redundancy and making sure that your links and connections are, excuse me, are available. From an access methodology, there are different ways to address different kinds of access means. Pardon me. We'll need to look at how do we provide access to the environment for internal users, external users. Again, going back to load balancers and making sure that, and link balancers, and making sure that we have aggregation and high availability for those external connections. The NetScaler products and things along those lines have built-in SSL VPNs for security, so then we're encrypting everything and making sure all the excuse me, all the information is protected before it gets into the data environment. So any questions? That pretty much wraps it up. As far as the things to consider and things to think about and what we're trying to accomplish relative to virtual desktops. So, Kate, does anybody has anything coming through the chat? Anybody have anything they'd like to know more about?
If at this time any of you do have any questions, please just put them in the chat box. You can do that by clicking on the green bar at the top that says Viewing Steve Harm's Desktop. And there's a little icon that looks like a message bubble and it says chat. You click that, and a box should come up where you can enter your question. So we'll wait for a second. In the meantime, while we get some questions from people, I just want to remind everyone about that last session. Thank you, Steve, for this one. This was great and very informative. And I'll be looking forward to our third conclusion to the Demystifying Cloud series.
So obviously the slide is how folks can reach me if anybody has any questions after the fact. And then certainly,
yes,
reach out to Kate and everybody within the iTech organization as well.
Yes, we'd be happy to help. Also, if there's someone that you think should be involved in the next webinar and you want them to attend, you can also send that to me. You can just email me at kate.mccauley, MCCOLLEY, at itechsupport.com. I'll put that in the chat box as well for you to have it. Let me see here if we have a couple more questions.
I'll just click to the last one here that Kate has your stuff on it.
Steve, I believe there is a question in your chat box.
Let's see if I can get to that. Chat. Okay. All right. Is there a viable solution to replace my VPN connectivity for end users? We have trouble with applications running over VPN. Really good question. There are a variety of different ways to do this, and we'll talk a little bit more about this in the next webinar, but as sort of a sneak peek, there are a couple of different ways to approach it. And the problem with traditional VPN access is that it's generally an extension of the classic PC connected to a server type environment. The downside being that coming in through a VPN, you're no longer connecting, at least for most networks, you're not connecting at gigabit per second speeds. You're now connecting at whatever amount of bandwidth is available for your connection through the VPN, and your bottleneck is either going to be the endpoint device, you're at home, you're in a Starbucks, you're in the middle of the jungle, or the bandwidth that's at the data center to receive that VPN connection. There are two perspectives that I'd like to talk about a little on this. One is the perspective from the bandwidth and the performance issues. I'll use an ERP or an accounting system as probably one of the most common applications for this kind of VPN access. When you have that bandwidth restriction between the PC and the server over a VPN, the performance of those kinds of applications is absolutely abysmal because there's a lot of data transfer going back and forth. In a lot of cases, the latency is so significant that you'll actually get timeouts and application freezes and lockups and so forth. I think anybody that's worked with a VPN in that kind of an environment can attest to that. The advantage of moving to a virtualized desktop environment is now all that data transfer between the application and the back-end database that it's accessing all stays contained within the data center. And the only thing moving back and forth between the user and that application are keystrokes, mouse clicks, and video refreshes. So from a performance perspective, you now can realize a user experience remotely that is either equal to or better than the experience that a user sitting on the local network in the same building as the data center will have. Excuse me. And then secondly, from a security perspective and a VPN access, you'll find everything from sort of classic SSL VPN type environments. Citrix NetScaler products offer a wide variety of entry-level to very sophisticated and very granular access methodologies, all built within their both virtual and hardware-based appliances. As sort of a moving up the chain from least to most complex, the web interface that was talked about in the previous slides can be configured to be SSL certified. Put an SSL cert on it, so you have encryption for that. The next step up would be something called the secure gateway, which is the secure gateway. It's like a web interface on steroids. Adds a little more security, provides a single interface for access into different environments, where the web interfaces, typically you'll have one for Zen Desktop, another one for the Zen app environment. By those two become consolidated at the first tier in the secure gateway. The secure gateway, really just the only security embedded in that is the SSL cert. You take it to the next step up, which is something called the Citrix Access Gateway, or a CAG. At the CAG layer, you can now do, it's the first layer at which you can begin to get granular about making sure that the device that's connecting meets certain minimum requirements. Things like, is it running a particular version of the operating system with a certain service pack installed? Is an antivirus present? Is it coming from a location or from a source IP that's recognized and validated? So the CAG begins to move into those kinds of environments and establish a greater level of granularity for validation of the remote device. The CAG typically talks and acts as a replacement for the, well, it's used in lieu of the secure gateway, and again talks to the multiple web interfaces that may be required to get into the environment, providing that sort of single unified entry point. Then when you take it up to the higher end, to the true NetScalers, the NetScalers now bring firewall capabilities and even greater levels of granularity into the environment. In addition, with NetScalers, you can create load-balanced environments where you have NetScalers on different circuits, and they can provide that sort of traditional, or what's normally a BGP-type environment for the end user, so you don't necessarily have to implement any kind of BGP, which can be both costly and time-consuming. So you have different ways to get in. Depending, again, you know, it's all about the use case. What are we trying to do? What level of security we're trying to provide? What kind of granularity and what kind of performance? And those conversations will drive the best methodology to get in. But the short answer to the question is yes, there are a variety of alternatives to the traditional SSL or the traditional VPN that both improve the security of the access methodology as well as the performance of the experience to the end user. So thanks for that question. Is there anything else?
I don't have anything on this end.
Okay.
So
well, let me thank everybody for taking their time today, and thank you, Kate, and the folks at iTech for this opportunity to work together. And I'll look forward to, if anybody has questions or comments after the fact, my contact information is there. So feel free to reach out and to either myself or to the folks at iTech, and we'll do our best to get them answered for you.
Yep. Thank you, guys. We will see you next time on April 25th. Have a great day.
Thanks.